Alright, welcome back everyone. We hope you had a great break and let's jump back in and kickstart the second half of our conference. So thank you very much for being with us today. Furkan Akal from Inco, who will explore how FHE can enable confidential computing within blockchain. Furkan, welcome to the stage.
Yeah, thank you. Yeah, it's Furkan from Inca Network. I'm working as a researcher and a technical writer. And today I'm gonna try to understand and explain for everyone, including me, how Inca works and how confidential compute can be achieved by leveraging FHE. So yeah, first, why confidential compute? Yeah, this is actually a problem statement. Our almost all blockchains are public and transparent, which looks and seems quite good in terms of transparency and not having the some hidden and dangerous things on the global stage. But this is also a some lacking feature because there are some things that people are not willing to reveal, like salaries, financial data, and like almost everything regarding to finance, right? So, and we came here to propose a solution for this, and yeah, these are some of the like some of the lacking things we like in front of the method option, like the bank accounts, payroll stuff. Like nobody wants to reveal their salaries to even their friends, institutions and enterprises, and they're never gonna reveal their financial status, like the agreements, transfers, and stuff. And of course, there are many Web2 blind use cases that we cannot onboard to Web3. And yeah, we're calling it the missing layer of the blockchain stack. Okay, we had execution, settlement, and data availability, and now we're proposing to add confidential compute into this stack. But how are we going to do it? By leveraging FHE, which is fully homomorphic encryption, a subfield of cryptography. In like the regular and traditional cryptographic schemes, you cannot compute on encrypted data. You encrypt a data, you translate the ciphertext, and the recipient decrypts the data with their key, right? But you cannot compute on the encrypted data, like what we call ciphertext. Here we have a fun example. Like you modify this image, but like the even on the encrypted version of it, this is of course a illustration. So basically, FHE allows you to perform like encrypted addition and encrypted multiplication. Like this is not all of it, of course. You can do comparisons. You can do all of the like computational operation you could imagine. But how are we doing so? We're proposing new types to Solidity at EVM and also some new operations. Um, I'm not sure how many of you are familiar with like the Solidity syntax, but of course we had integer types like the uint8, uint 128, 256 and stuff. Also Boolean address and bytes. We're proposing to add like encrypted new versions of these types. For instance, if like integer uinteger 8 is standing for 8 bits of integers, the encrypted uint8 is representing the encrypted version of the integer type that we used to. Also, we have the operations here. TFHE is the FHE scheme that we are using in FHE VM setup. And for instance, TFHE.add helps you to perform encrypted addition. Similarly, does the multiplication, and EQ is of course standing for the equality. And yeah, finally, we have also randomness. You can create random variables by on an encrypted manner and without revealing any plaintext data. And all of these are built for implementing Inco Layer 1 for like as a confidentiality as a service to existing many blockchains, more than 200. Of course, starting with Ethereum and like Arbitrum, Base, Optimism, ZK Sync, Scroll, Avalanche, and goes like that. And as we use okay, yeah. Before moving forward with the implementation, let me also mention this is not only FHE, of course. We're also leveraging MPC and ZK. ZK is used for proving that you're the owner of the particular data. You're submitting encrypted data to the chain, to the global state, but of course you need to prove that you are the actual owner of the ciphertext, and this is where we leverage ZK. Also, we use MPC because even though you don't need you don't actually need MPC to decrypt any FHE ciphertext, as this is a blockchain implementation. Of course, decentralization matters, and no single entity should own the authority of decrypting ciphertext of the entire network. So we're attesting this task to the entire network of validators, and this is an MPC network. Each validators has a share of the secret key of the global network, and when at least 70% of the validators come together, they're allowed to decrypt any ciphertext by using the global key. Yeah, this is the one that I was gonna mention. Yeah, of course the most intuitive way to write code is writing Solidity, right? Because of course Rust is used, the other coding languages is used, but the Solidity is the most favorite one, and the Ethereum uses it. So FHEVM library is a Solidity library where we implemented of course together with other teams, the encrypted types and encrypted functions into Solidity. Basically, you write normal Solidity contract. You just add some needed parts of the confidentiality by using TFHE library. Yeah. So okay, when we talk about FHE, the first question always comes as okay, FHE is good, but FHE ciphertexts are really sizey, and yes, this is true. So that's why we're using handles. Handles are like some numbers, way less sizey and representing each ciphertext. So this is the method that we use for handling the size and cost problem within FHE. Yeah, computing over handles or of course ciphertext is quite easy and straightforward. This is one of the examples that you can think of. Here, Bob transfers some USDCs to Alice, and in the background, the this line is run tfhe.add balance Alice to and hidden amount. Here, hidden amount is an encrypted uint, one of the uints probably, and no one is able to see it. So this is actually what we bring. Yeah, this is the similar thing that has to generate the handle, and yeah. Okay, we have many use cases, and there is no limitation here. If things, if you have something in your mind regarding confidentiality or privacy in blockchains, you can leverage FHE and use Inco's tech stack to implement your idea. Yeah, if we dive into it a bit, this is of course one of the most common use cases, confidential ERC20, and I'm not sure if you heard it, but a couple of weeks ago we published our work with Circle, but we collaborated with them to publish a white paper and also a proof of concept implementation of a up and running confidential ERC20 token. The main difference is here that you can see. No, in normal ERC20s, of course, the balances is a mapping from an address to a integer. In the confidential ERC21, of course, the address is mapped to encrypted integer, so that the outside viewers or the other users are not allowed to see how much tokens are sent. Yeah, on-chain poker might be another use case in terms of on-chain gaming or FT gaming, because without confidentiality or without the privacy aspect, of course, not possible to implement a poker into Web3. So Inco makes it possible. Yeah, this is the first fully on-chain mafia game. It's built in East Global, New York. One of the hacker teams built it in our like the sponsorship. You can find it on GitHub. And yeah, one of the most important ones is of course MEV protection, because as the swap amounts are also hidden and encrypted, it's impossible to do sandwich attack, and I think this is also a good thing for DeFi. Um, yeah, of course, private voting, voting is a quite a hot topic these days because of the U.S. election, and like some people always discussing if voting should be private, what kind of outcomes that would bring, and stuff like that. Oh, and FHE makes it possible to fully on-chain private voting in any Ethereum compatible or EVM compatible chain by using Inco. Yeah, all of these are possible, and with even 20-minute onboarding, as we're using Solidity, and it's quite easier to get onboarded, even if you have no idea about FHE, even if you never built on top of FHE VM. Only you should see our documentation, and of course, please visit our Discord. And if you're gonna hack on during the East Global Hackathon, please see our booth. Our DevRel team will be there, and I think they will be really happy to support you. Thank you.
Thank you very much, Furkan from Inco. Given we have a bit of time, feel free to add any final note that you would like to share to our audience.
Yeah, depends what kind of what kind of-
Anything you would like to share about the recent innovation or about Inco?
Yeah, sure. So like I thought I was gonna out of time, so like I guess faster, but yeah, okay.
No, feel free to take the floor.
Yeah, sure. Yeah, I can. Yeah, I can elaborate on confidential RF1. Because okay, this was of course quite possible with FHE, and we knew it from the very first day. But like as I mentioned, like our final work with Circle, I think is something really huge, because like we have really few teams work on FHE in Web3. And as Inco, I'm personally really proud that we were the first to do something like this, like in front of everyone. And Circle is like of course one of the leaders of the stablecoin industry, and like the fact that they support confidentiality in ERC20 tokens is I think something huge. And like we always talk about mass adoption, we always talk about like the migrating and onboarding the Web2 people into Web3, but we cannot do it without promising them about confidentiality, because like I mean we're not even promising that their salary is gonna be private. So I think this is one of the really important milestones, and that's why I see FHE and FHE on chain really promising in terms of both cryptography aspects and also blockchain aspects. And I would love to hear more. I would love to see more people onboarding to FHE and like FHE VM developers.
Sounds good. Thank you very much, Furkan from Inco. And we will take a short break, and then we will continue with more session from our speaker in this video stage room. Thank you.